We all want our AI language models to, work really well for us. But getting the instructions right sometimes feels, well, a bit like guesswork.
It really does.
Yeah.
And how well it works often comes down to the instructions can give.
Yeah.
The prompts.
Right, prompts.
And there are basically two main kinds, right? You've got your system prompts. These are like the big picture rules for the AI.
Foundational stuff.
Kind of, yeah. And
Ah,
to shape its general behavior.
yeah.
And then you have user prompts, which are, what we ask it to do for a specific task.
Okay. And it feels like most of the effort, most of what people talk about is optimizing those user prompts, like how to ask the perfect question.
That's been the main focus, definitely, tuning the user prompt for this specific job or that specific query.
But there's this other layer, the system prompt.
Exactly. And optimizing that foundational level.
Hmm.
Well, that's a huge, largely untapped area. Getting that right could make the AI better across lots of different tasks, maybe even different fields entirely.
Which brings us to the research we're looking at today. It's a paper called System Prompt Optimization with Meta-Learning.
Mm-hmm. And it tackles this very problem with a pretty novel approach, I'd say.
It introduces something called bilevel system prompt optimization. Sounds complex.
It does, but the core idea is really interesting. So our goal in this deep dive is to sort of unpack how this method works.
And figure out why it could be such a big deal for how we use these language models going forward.
Right. So let's dig in. We've got system prompts and user prompts.
Okay.
The paper really stresses that system prompts are meant to be task independent. They set the general stage for the LLM.
Well, the user prompt is very specific to what I need right now.
Correct. Like a system prompt might be something like, be a helpful assistant, be concise.
And then my user prompt is, summarize this article for me.
Perfect example. That distinction's key. And the paper's argument is that optimizing that first part, the system prompt, has some real advantages.
What kind of advantages are we talking about?
Well, one big idea is invariance. A really well-tuned system prompt could be invariant.
Invariant meaning.
Think of it like a solid house foundation. It supports all the different rooms, the tasks you build on top, without needing huge changes every time you add a room.
Ah, okay. So a good system prompt works well across many different tasks.
That's the idea. It should be valuable across a whole range of tasks and maybe even different knowledge areas.
And does it make the AI better at handling different user prompts too?
The research suggests yes. A strong system prompt seems to create a more, let's say, resilient framework.
Mhm.
The LLM can handle varied user requests better and adapt to new situations more easily.
It sounds like you get more synergy between the base instructions and the specific requests.
That's a good way to put it.
So if these system prompts are so important, why haven't people focused more on tuning them? The paper must touch on that, right?
It does. It brings up a really important point. Most traditional prompt optimization work just targets those task-specific user prompts.
Which works fine for that task.
For that one task, sure. But those optimized user prompts often don't generalize well. They don't transfer easily to new or different kinds of problems,
So you end up having to re-optimize the user prompt every time you face a new challenge.
which can be pretty inefficient.
Yeah.
And by ignoring the system prompt in that optimization, we might be missing a more fundamental way to boost the LLM's performance overall.
Okay, so that brings us back to this bi-level system prompt optimization. How does that try to fix this? A bi-level. Sounds like two levels.
You got it. The paper calls it bilevel because there's this
Mhm.
natural hierarchy, right? System prompts and user prompts.
One general, one specific.
Exactly. So the higher level is optimizing the system prompt for that broad applicability. That's level one.
And the lower level.
That's level two.
Right.
Optimizing the user prompts to get the best results on specific tasks given the current system prompt.
Ah, I see. So they influence each other.
Right. The goal is to find a system prompt that not only works well with lots of different user prompts, but also generalizes effectively to tasks the AI hasn't even seen during the optimization process.
And the paper uses meta-learning for this. How does meta-learning fit in? That sounds like another layer of complexity.
It can seem that way, but meta-learning is basically learning to learn.
Learning to learn.
Yeah, you're training the model not just on specific tasks, but on how to adapt and learn quickly across a whole range of different tasks.
Like teaching someone how to study any subject, not just teaching them history.
That's a great analogy. So meta-learning trains the AI to be a more flexible learner overall. And that's perfect for finding a really robust, adaptable system prompt.
So this framework they propose, MetaSPO.
Right, MetaSPO. It essentially meta-trains the system prompt using a diverse mix of user prompts and tasks. The idea is to bake in that ability to generalize right from the start.
And you mentioned it's iterative. It updates both prompts. How does that work mechanically?
So inside this MetaSPO framework, you've got these two loops working together. There's an inner loop.
Okay.
That inner loop focuses on optimizing the user prompts for specific tasks, assuming the current system prompt is fixed for a moment. It tunes them up for best performance on those tasks.
Right, refining the specific instructions.
Then, once those user prompts are looking good, the outer loop kicks in.
And that updates the system prompt.
It does. The outer loop looks at how well the current system prompt performed across all those tasks, considering the newly optimized user prompts from the inner loop. And then it adjusts the system prompt.
So it's this constant back and forth, tuning the general instruction based on how well the specific ones work and vice versa.
Kind of like a continuous improvement cycle, making sure the system prompt gets better at supporting effective user prompts across the board.
Did they test this out? I assume the paper includes experiments.
Oh yeah, quite a few.
Yeah.
They tested MetaSPO on 14 tasks the model hadn't seen before.
Unseen tasks. Okay.
And these spanned 5 different areas. Things like medical text, analyzing reviews, reasoning problems, safety checks, and even grounding tasks.
A good variety. And how did they test it?
They looked at 2 main things. First, what they called unseen generalization. That's just taking the optimized system prompt and using it directly on the new tasks without tweaking the user prompts further.
Just plug and play, basically.
It's sort of, yeah.
Okay.
And the second scenario was test time adaptation.
Which means?
That's where they do allow some further optimization of the user prompts for the new tasks, but they keep the MetaSPO optimized system prompt fixed.
Okay, so seeing how well the foundation supports further building, in a way.
Nicely put.
And what did they find? Did MetaSPO actually help?
The results look pretty good, actually.
Yeah.
In that first scenario, unseen generalization.
Yeah.
The system prompts, optimized by MetaSPO, consistently did better than the standard methods they compared against. It showed they really could generalize to new, diverse tasks and user prompts.
That's promising. What about the adaptation scenario?
It's also positive. They found that using the MetaSPO system prompt made the test time optimization of user prompts much more efficient.
Meaning faster.
Faster, yeah. They got better performance improvements with fewer steps needed to optimize those user prompts for the new tasks.
Okay, so let's try and recap the journey here. We started with the difference between system prompts, the general rules, and user prompts, the specific tasks.
Right, and how most work focused on user prompts.
Then we looked at the challenge. How do you make system prompts good across many different tasks, making them generalizable?
Which led us to this paper in MetaCPO.
Yeah, this meta-learning idea, the bilevel optimization, this whole iterative process of refining both the system and user prompts together. And the experiments seem to back it up, suggesting this approach gives you system prompts that are more robust, more adaptable.
And more efficient when you need to adapt to new tasks later on.
Yeah, the results do sound encouraging. Better performance on unseen tasks, faster adaptation. It points towards AI that's maybe less brittle, more versatile.
It certainly suggests a promising path forward for building LLMs that aren't just good at one thing, but are more generally capable.
It really makes you think, doesn't it? Imagine interacting with AI where you don't have to constantly micromanage the instructions for every slightly new thing you want to do. Instead, you have this underlying system, this foundation, that's already well-tuned to understand and help effectively across the board. That feels like a pretty fundamental shift in how we might partner with AI.